Probably 10.
Do you guys finish all of them?
No, not 10.
No. Okay.
I didn't really understand how to do 10.
Neil, write your problem. Ray, right side.
For 10?
Neil, right, for 10. Okay. Then Ray, how about you?
I also don't know how to do this one.
10?
Yeah, 10.
Okay, but any more? Or just 10? Just 10, right?
Yeah, not really.
Okay, anyway, let's go to question 10. A regular nine-sided polygon is inscribed in a circle of radius 3 meters. Find the area of the polygon. Give two forms of the answer. One is in trigonometric function, the other by calculator, right? Yeah, how about we just go to find. So the only condition here is the 3 meter, right? Inscribed in a circle of radius 3 meter. We want to find the area. Nine-sided polygon. Yeah, how about we go to search and find one. Oh. Yeah, it's like this. Oh, come on. All right. Oh. Yeah. So this is not the circle they mentioned. Radius is 3 meter, right? Yeah, as it's 9 side, so it's makes by 9 equivalent triangle. So you just need to find one triangle's area. Yeah, for example, this one. Then time 9, you get the area for the polygon, correct? Now this is a isosceles triangle. Anyway, if you make the angle bisector, it's also the perpendicular bisector for the base. Yeah, so you can think this is like, right, let's call it A, B, C. We know this is 3 meter. Let me just write 3 here. And each angle is 40 degrees, so half of it is 20 degree, right? 20, yeah, it's not 26, it's 20. Now, can you calculate the area for triangle ABC? Yeah, please do it. So first, don't use the calculator. Just express your answer in trigonometric ratio. So could you try? This is for Neil. This for Ray. Right side for Ray. Find the area of triangle ABC.
Ooh. That's 30 degrees, right? Or is it 20 degrees?
This is 20 degree.
Okay,
You
okay.
say the whole angle ABC is 40 degree. Half of them is 20 degree. Let me call this point D. Yeah, show some process and steps. Do you guys get the idea? I suppose it's not so hard.
Yeah, I'm solving it right now.
Oh, you also. Neil, how about you?
I'm trying.
You are trying? Yeah.
Yeah.
Show your works on the screen.
Wait. Fish.
Hmm.
Should it be like, actually it's just 9.
Okay. Ray, are you done?
Well, I think so. Wait, let me
I don't
change
know
something.
fast.
$81. Okay. So you're done, right?
Yeah, I think so.
Yeah, this is not the area for triangle. It's for the whole polygon, right? Let's call it A of polygon equal to this. Yeah, I get same answer. Of course, use calculator. You can get approximate value, right?
Yeah.
Yeah, let me explain it a little bit. For triangle ABC, we know the formula for area is B means base, H means height. Yeah, here this is like half B, right? So the B is double of half B. Half B is CD. So CD is sine 20 degree equal to CD over BC. So CD equal to BC. BC is 3 times sine 20 degree. Then H is 3 times cosine 20 degree. right? So together we get 9 sine 20 degree cosine 20 degree. So a area of the polygon equal to 9 of this, right? Then we get this answer.
Hmm.
Okay. So any more questions?
Not really.
Ray, you are okay, right?
Yeah, I think I'm fine.
Neil, more questions?
Not really.
Not really. Okay, let's go next chapter. Chapter 7. The trigonometric function.
Water really fast.
Mm.
Okay, I'll be right
Reading
back.
Mayor.
Can I get water?
Oh yeah. Let
Okay,
me know when
perfect.
you come back. Are you back?
No.
Please open, no longer here. I need when to look. Simulation, look at the heart.
That's only because. Okay, I'm back.
Okay, so do you guys have an idea about the reading Mayor?
Yeah, it's basically like
Yeah, for example,
the arc
15
of
degree. Rewrite as reading Mayor, what it is. So again, Neil, right. If 15 degree, it should be what? Yeah, write your answer, please, if you know how to do it.
Would it be like pi over 12?
Yeah, you can
Yeah.
use pi. It's fine.
It's
You
pi
don't need
over
to go to
12.
use calculator.
Yeah, I just.
Just provide the exact answer.
Is it pi over 12?
Yeah, it's pi over
Just write your
12.
answer, please. Pi over 12. Okay, yeah. I think so. That means the pi means 180 degrees. So use 15 divide 180, right? Then this means, yeah, so after simplify you get this. Okay, now another question. If you can do it, then we can, if in reading Mayer it's 1, then this means how many degree?
I think it's around like
How many degree?
I think it's around like 57 something, 57 something.
57 something, yeah.
Yeah.
So again, pi means 180 degree, right? So use 1 divide pi, then time 180, right? Then we get answer. Yeah, so let me write the pi, hold, 180 divide pi. Yeah, we get it's about 57.3 degree. Yeah, Okay, then we can, I suppose we can pass this, as you guys already know. The reading measure of an angle. Yeah, here she'll use the arc length, divide the radius, get reading measure of the angle. Property summary. Oh yeah, here shows something tightly related to physics. Angular speed and linear speed. Angular speed just means the theta over t. Yeah. So in a fixed time, if the theta is bigger, then means the angular speed is bigger, right? Then for linear
Mhm.
speed, equal to distance over t. Yeah, then later maybe we have a case, find both the angular speed and also the linear speed. That's fine. Yeah, that being said, for example, on this, we just call it disk. On this disk, if a point is here, a point is closer to the center, then they have same angular speed, but have different linear speed, right?
Mm.
Yeah, you can call linear speed, we suppose equal to angular speed times the radius. So on same disk, then we say the omega is the same. Then the bigger the radius, the bigger the linear speed. Okay, here's your new unit. So let's try to do this. Rate, the rotation rate is 100 revolution per minute. What is the angular speed in radian per minute? Find the linear speed. Yeah, could you try this? Let's just do part A. Yeah, we don't need to do part B. Again, so left, right.
Uh,
Okay, so Ray already get the answer. Okay, so let's say 100. Revolution just means one whole circle, so it's 2 pi, right? Oh, so you get 20 pi? Suppose it's 200 pi, right?
Oh, yeah, yeah, yeah.
Yeah.
Okay, I made a mistake.
Okay, so let's pass this. V equal to D over T. Yeah. Yeah, this is the formula I already showed. Backside. Okay, again, let's find some. A, B, either C. We don't have C. Let me see. Okay, just A and B. How about let's find the one here? 41. Yeah, even go bigger. Yeah, think about the problem 41. Hold, give me one moment. I would like to divide. So top is for Neil, bottom for Ray. Yeah, you just answer A. Answer is what? B. Answer. Answer for C. Answer for D. I'm gonna speak.
Oh, wait, is RPM rotations per minute?
Yeah, RPM means revolution per minute.
Oh, thanks.
Yeah, here still per minute. So you just need convert 100 revolution to how many readings? Ray, here for the speed, you need to mention its unit,
Oh,
right? Yeah, in physics, the basic unit for speed is meter per second. But you can choose your own unit.
just stick with this.
Cm per minute. So why you get this answer? Why you get 1000?
Because isn't like the formula like its radius times its rotation speed or
So the
revolution
formula
speed.
is like a linear speed. V, let me write here, V equal to angular speed, we call omega, times the radius, right?
Yeah.
So omega is over here, 200 pi, then time r. As you just use centimeter. Yeah, then suppose pi still there. If you don't round it, right? Anyway, think about it. And if it's not correct, hold. If it's not correct, just means cancel. Then write the correct answer nearby. Yeah, Neil, keep going. Yeah, the formula for part B is here. Oh, come on. Okay, 200 pi. It's 200 or 2000?
2000, it's 2000.
2000 pi.
Yeah.
Unit is centimeter per minute, right?
No, it's I would say yeah.
Yeah. Okay. Then keep going, part C. Okay, here has hint. Use it. Neil, I write for you. So it's just 200 pi multiply 10. So we get 2000 pi. Yeah, but
Wait,
this is not a standard unit. The unit is centimeter per minute.
does the
Normally
10
we
come
use
from the
meter per
radius?
second. Right.
Does the 10 come from the radius of the big one?
Yeah, the 10, yeah, from here. You are right. Okay, yeah, I think it's good. Yeah, for part C, you just use omega equal to linear speed v over r, right? So that being said, you have linear speed 2000 pi over r for this small wheel.
And you
It's 6. Then after simplify, we get 1000 pi over 3. Yeah, circuit. Then part D, the angular speed of this monowheel in right, keep going, finish part D. Then you are all done. Okay. Yeah, after divide 2 pi, because 2 pi means 1 revolution, right?
Yeah.
So divide 2 pi, you get this. So who is rotate faster?
The big one. Wait, no.
Yes.
Probably the small. Wait.
There's a small
This
one.
smaller one, right?
Yeah.
Yeah.
Yeah, because this is 100. Here is like 167. Yeah, round to 167 round per minute. Okay. Yeah, if you want, you can screenshot. Then, oh, this is from part B. Okay, good. Okay, let's go next section. Trigonometric function of angle. Initial side, vertex, terminal side. Yeah, here show a standard position, just like about here, right? Fixing. Then another side can rotate, either clockwise or counterclockwise. For counterclockwise, we take it as positive angle. The clockwise is negative angle. Then cosine, just as simple as COS. Anyway. Yeah, this is like a unit circle definition, right? In the unit circle, find the terminal point. Then its trigonometric function defined as this. It matches with the definition from right triangle. For example, when it's theta is an angle within 90 degree. Then we also have terminal point x, y here. So, for example, for sine theta equal to OPP, operate over hypotenuse. Here, hypotenuse is 1 because it's unit circle. The operate is y. So that's the reason it's equal to y. All right. So they are matched with each definition. Yeah, here mean they are reciprocal from the left one. This. And we need to pay attention to make sure it's defined. That means that the denominator cannot be 0, right?
Mm.
Yeah, so through the definition in unit circle, the angle theta can be any value from negative infinity to infinity. Yeah, another is normally we would like to use theta in reading measurement. In this way, we don't have the unit like 30 degree. We don't have the unit degree, right? It's just a pure number, 1 pi, 2 pi, yeah, like this. Yeah, so in this way, we call this is a function. For this, its domain. Yeah, now let's try to find its domain. Let me do one, then you guys can each do. I mean, I do 1 row. Yeah, I just do first row. Yeah, by the way, in future, actually, we'll call this is y equal to cosine x. Because normally we use x as the independent variable, right? So x actually is an angle. Then we'll call this y equal to secant x. Yeah, anyway, if x is an angle in this function, the domain can be any real number. That means that from negative infinity to infinity. For the function value, that means that the range. Yeah, you can say this just equal to x coordinate. Now x means coordinate. So it's just between this, right? Means negative 1 to 1. So the range is negative 1 to 1. Yeah, if for secant, we know x cannot be 0. Yeah. Sorry, now x is the input, means is the angle. Then let's say what kind of angle x cannot take. I know here has some mix. Sometimes x means the x coordinate. Sometimes x means the function's input, right? So anyway, if it's this, x coordinate cannot be 0, then it cannot at y axis, right? That means that the angle cannot be 90 degree or just half pi or 270 degree. That means that 3 over 2 pi. Then it's for this y equal to secant x. Then its domain is, yeah, you can say there can be negative half pi, 2 half pi, then jump through this. You add a pi. So that means that it can write as n pi minus half pi, then n pi plus half pi. N can be n just integer, any integer. Anyway, this looks like a little bit of complicated, right? But I suppose the coming future will talk more on this. Do you guys have questions?
Nope.
Yeah,
No.
if you feel a little bit of confusion, it's okay. Yeah, because here sometimes we wanna x if per the functions expression, normally we use x as input or independent variable. But if for coordinates, we use x as x coordinates, right? Okay, so don't worry. Yeah, when you do this kind of problem, you'd better, if you feel confusion, you'd better draw the unit circle to help you. Now let's try one, refer to figure 6. How about this by Leo? Part B by Ray. Let me give you whiteboard. Okay. So Leo here, Ray here. Yeah, for anything you don't know, just let me know. I'll give you some hint. Cosine theta. Okay, very good. Could you do one more? For example, yeah, Leo, just do one more.
Whoa. Um. ah,
Cosine beta, sine beta. Oh. Yeah, actually they are the same, right? Because they have same terminal side.
Yeah.
Yeah, let me check, make sure. Okay, then cosecant theta is this. Okay, yeah, good. Then let's go next. Coterminal. So again, here as they have coterminal. Suppose the function value for negative pi and pi should be the same, right? Let's say if yeah, Here they just use it to get same. Yeah, here you can use calculator. But make sure in your calculator there is when you input angle, suppose there are two forms. One is in degree, another is in radians, right?
Yeah.
So let's try to do one. Okay, let's forget this. When we go to exercise, we'll try to do one. Two. Yeah, now we can do this. How about yeah, this time we change. Leo do part B, Ray do part A. You can use calculator.
We can.
Yeah,
use
just use
calculator.
calculator. You don't need to use figure eight.
Mm.
Wait, do I have to be in radian mode?
Uh,
I think I do. Wait.
say it again. Leo, what's your
I
question?
have, I have to be in radian mode for this, right?
This means reading. When -3 means -3 of reading instead of -3 degree. Is this your question?
Yeah.
Yeah. If it's degree, we'll show the small circle on the top right side, top right. But if without this small circle, it just means reading. Okay. Yeah, suppose they have same cosine value, but operate sine value. Yeah, we'll show this in coming section. Means for cosine function cosine x, it's an even function. For sine, it's an odd function. Okay, let's keep going. Trigonometric function. Okay, we'll pass this. Now, part A. Just part A. Okay, let's pick one from here. use your calculator to evaluate. Oh,
Do we do all three of them?
no, this for Neo, this for Ray.
Okay.
Evaluate. Yeah, three of them. Yeah, how about just you do one of them? For example, Neo do secant theta. Ray do cotangent theta.
So do we do all of them, or we only do the two of them?
No, you just do problem 77.
Oh, okay.
Neo do 75. Just for one of the trigonometric function. Neo is secant. You do cotangent. Yeah, in your calculator, for example, I use a calculator from my iPhone. We don't have the function like this, but you can find the basic one, sine, cosine, tangent, then derive to get this, right?
Yeah. Hmm.
Do I do like
Oh, let me see. I don't get this kind of answer.
wait, I don't really get how you do it.
Oh, hold. So Ray, maybe this is not correct. Could you double check? 9 means 9 readings, right? Not 9 degree.
Yeah, I am using radians. Wait.
You already use
Oh, okay,
reading?
I see, I see, I see.
Neil, you mean you don't know how to do?
Yeah.
Okay, for secant theta, it's equal to 1 over cosine theta. Now the theta is 2.06, right?
Oh, so I
Yeah,
thought you
use
did
your calculator
inverse.
to get it.
Okay.
Hmm.
Yeah, this time I suppose
Yeah,
it's correct.
I accidentally typed in
Okay,
an
this is
extra
correct.
number.
Okay. Maybe we can have one more. Now let's do 29. 29 part A. Then 30 part B. Okay, hold. Give your whiteboard. Yeah. Again, here, Ray, here. Ray do 30 part B. Neil do 29 part A.
Yeah.
Unit circle definition. Whether the given quantity is positive or negative. For 31. So this is within 30. You just determine if it's positive or negative, right? You don't need to get the exact value. Okay, so how about do both A and B? So Neil, A, B, Ray, A, part B. Part A, positive.
No,
Let
it's
me
for
check.
B.
Sign
It's
one.
for B. It's for
Okay, I'm
B.
doing.
Yeah.
We're doing 29. I'm doing 29, right?
Oh, yeah, you do 29. Part A, sine 1 minus sine 6. So you mean both A and B are positive, right?
Yes.
So positive. Neil, how about you?
So, uh, wait, give me a second. I'm gonna say
So cosine is which coordinate? X coordinate or Y coordinate?
this. Cosine is X. Wait.
X. So you
Never
say
mind. Never mind.
cosine 1, angle 1 is here. So they are both positive, right? So of course it's positive. Then cosine 1 minus cosine 6. Cosine 6 is bigger than cosine 1. So when you're small number minus a big number, you get negative. Yeah. Okay. Yeah, then we just finish this section. Let me see how many sections we have. 4, 7, 1, 2, 3, 4, 5. Okay. Then we'll go to this. Yeah, let's take a break first. Let's come back.
Okay.
Section 7.3. Are you guys ready?
Yes.
Okay. Evaluate the trigonometric function. How to evaluate? So I suppose the important thing is find the coordinates for the terminal point, right?
Mm-hmm.
Then maybe you need to solve right triangle. Yeah, for example, let me generate draw angle. How about, for example, an angle is here. Then this is theta, right?
Yeah.
Yeah, you can use its reference angle, theta prime, which is in this right triangle, to find its leg. This is like the y absolute value. This is x absolute value, right? If you talk about the sign for the x and y, it's really depend on the terminal point is located in which quadrant, right? For example, if it's quantity 2, then suppose y greater than 0, x less than 0. So in this way, you find its epsilon value, find its sign. Then you can get x and y. Then finally get the trigonometric function for angle theta. Yeah, here show trigonometric value for some spatial angles. Yeah, it's cool if you can remember all of them, but if not, at least you can induce it yourself, right?
Wait.
Yeah, you have a question?
No, I don't.
Okay. Yeah, okay, so here talk about the reference angle or reference number. Because your reading angle measure is a real number. Then what means reference number? We know reference angle. Let's say if there is definition. The reference angle, reference number for is 3 pi over 3. So it's just like a reference angle in radians, right?
Oh, jeez.
So let's say here again. When radians measure is used, the reference angle is sometimes referred to as the reference number. Okay, this is its definition. Now let's evaluate finite quantity. Yeah, let's see how they do it. We just see part A.
Yeah.
See figure 6. The reference angle is this. So sine 45. The terminal side in quantity 2. So y is positive. So sine is positive. Okay. Finding the value of with negative measure. So first you should go to find its terminal side, right? Then use reference angle. Anyway, so it's here, reference angle 60 degree. Suppose it's x and y for terminal point are both negative. That means that cosine, sine, both negative. Anyway. Okay, let's do some exercise. A, B, no C. Okay, find some from part A. And you want. Come on. So Leo do this. Ray do this, C and D. secant. Yeah, let's use the unit circle to find these 2 points. Secant. This is like, if it's 3 pi, then it's here. But it's, okay, anyway. So the final is about here. Yeah, if we call this is theta. If I call this is theta, alpha, then how about alpha? Use different color. Alpha is 3 circle 1. Yeah, it's about here. So this is related to theta prime, alpha prime. Now let me check A. Yeah. Okay, this is good. Then B, cosecant. I suppose this is not correct. Now tangent. Is the terminal point I drew correct? Do you think it's correct? The green is the place for the angle 17 pi over 6. The purple is for angle negative. Neil draw this black, right? You think it's here? No. Neil, you draw theta or alpha? Tell me. I don't think it's correct position. Right. This means 2 pi plus 5 over 6 pi. 2 pi means a whole circle, so you can ignore it. Anyway, so double check. If I'm wrong, make sure let me know.
Oh wait. Oh my. I forgot to unmute myself.
Oh,
Okay, yeah. Wouldn't this be negative 17 pi over 6? Because that's one rotation, and then it
mm.
doesn't reach another pi, so it's
No,
less than,
when it's positive, means you should rotate uh,
yeah.
counterclockwise.
I'm talking about the negative one, since did you say that this one was negative?
Oh, yeah. So you talk about what I named as alpha, 对吗? Right?
Yeah,
No, it's not correct. It
it's
should be
not.
the position I mentioned.
But why is it there though? Because if it starts from
Means
here,
this is
that's
negative 2 pi minus 5 over 6 pi, correct? Negative 2
yeah,
pi, you can ignore it because it means a full circle, right?
yeah. But if negative 5
Oh,
pi,
hold.
yeah,
Let me
negative
say,
5 pi over
yeah.
6 is less than
Yeah,
pi.
I get it wrong. So it's here. Then let me check. Yeah, so I'm wrong. Oh, come on. It's hard to cancel. No, I'm sorry. Okay, forget it. Anyway, what you draw in black is the correct position. Then, oh, sorry. Yeah. Then let me check if it's negative 2. Find the sign first. Yeah, sign is half. Then, yeah, this is correct. I get it wrong. Yeah, after full circle, you should start from here, right? Then let's say what from Ray. So in first term, you get wrong. Now, tangent means this. Tangent is negative. Then it should be y over x. Then this is not correct, right? It's like 1 over 3 radical. Yeah, anyway,
Mhm.
should be this. Right?
Yeah.
Then part B
Mm.
is here.
This should be
Again, tangent is still yeah, still this kind of value, but which is positive. This time is positive, so not this. Suppose it's right.
Yeah.
Okay. Part B. Yeah, how about let's try 33. Require no trigonometry. In exercise 30, the coordinate point Q in the following figure. In unit circle, P is P, PO and QO are perpendicular. How should we know? I suppose we can make two rectangle, right? This is 1. Let me use a different color. This is another one. So this angle, if we call it theta, then this angle also theta, correct?
Yeah.
Yeah, then we have this called AB. Who is A? A is this, B is this. And of course, A, B are both positive. But now the length of this is A, this is B. But for X, it's negative, so it's negative B. For Y, it's A and it's positive, so it's just A. Then we get it, right? Okay, they use the 9 equation. But we do use the trigonometric or congruent triangles. Okay, let's finish this section. Go next. Algebra and the trigonometric function. Notation convention. What's this mean? Hmm. Yeah, just talk about some habit. Combine nectar. Oh, they're simply writing sine theta just as S, cosine just as C, right? Okay, factor. Forget. Here means some algebraic operations for trigonometric, right? Property. Yeah, just some basic thing. Use identity to calculate the trigonometric function. Okay, what you should pay attention is when you get this, cosine theta square equal to 5/9. So theoretically, cosine theta can be either positive or negative, right? But when they say theta is just in this kind of angle range, then maybe cosine can just take either positive or negative. Yeah, it's depend on which range this angle is located. Use identity to simplify. Anyway, simplify. Or prove. Yeah, let's do some exercise ourselves. C. This time we get part C. Okay. Now part A. How about let me do one first? Ray, you can pick one for me.
Okay.
Which one?
Let me see.
Yeah, ideally it's like odd number.
Why don't we do 55?
55. Yeah.
Mhm.
Prove is identity. Okay, let's say. So secant or even tangent is a little bit of strange compared to sine cosine. So we'd better let it go to sine or cosine first, right? So let's say, yeah, so I would like start from left side. This means 1 over cosine alpha minus cosine alpha. The top is sine alpha square. Okay, then per the algebraic formula, we have get cosine square over 1 minus double of them 2 sine alpha, then cosine alpha square plus plus sine alpha square cosine alpha square, right?
Mhm.
Yeah, anyway, we can write as cosine alpha square 1 plus 1 minus sine alpha. Oh, hold. Yeah, so yeah, I just keep watching. We want to go to here. Just has sine alpha. So this give me hint. Maybe I'd better translate cosine alpha to sine alpha, right? So we know cosine alpha square plus sine alpha square equal to 1. Then cosine alpha square equal to 1 minus sine alpha square, right? So for the top, it's just 1 minus sine alpha square. Then keep going. This is 1 minus sine alpha square. This is a difference of squares. So it's 1 plus sine alpha, 1 minus sine alpha. Then I can cancel 1 minus sine alpha. Cancel 1. Here go to 1. Then I get the answer. So it's right hand side. Right? Any questions?
No.
No? Okay. Now let's find one. What's here? Write in terms of sine, cosine, and simplify each expression. Okay. Okay. So Yeah, this time I change the order. So Neil do this. Ray do this. Yeah, you need to show your process instead of just say, oh, it's true. No. Mm. Ray is correct. So it's in third quantity. So its cosine is negative, tangent is positive, right?
Mm-hmm.
Okay, good job. Yeah, you can think. You can also think problem 66 in your own workbook.
I'm just like, for some
Or
reason,
if
I
you
just
want,
thought tan A tan B equals tan A tan B times tan A plus tan B. Like,
yeah,
I
Ray, you
don't
can
think
also
that.
think on it and write on your left side.
But are you supposed to prove it? Like
Oh
to
yeah, it's
prove
like
it?
proof.
Oh, okay, okay, I see.
Yeah, you just go to left side equal to right side. After all kinds of conversion, right side go to left side, then you prove it. Can you guys show something? Or how about
I'm just
yeah.
not sure how to get rid of the tan A plus tan B.
Yeah, so from left side you cannot get a hint. Then you can starting from right side, right? So let me try from here, right side. Here has tangent, cotangent. Anyway, the final answer just has tangent. So definitely will convert the cotangent to tangent, right? Anyway, it's tangent A plus tangent B. Here is 1 over tangent A plus 1 over tangent B, right?
Mhm.
Yeah, then in order to remove the denominator, we'll both multiply tangent A tangent B. Here also tangent A times tangent B. Right, then we can get, yeah, for the bottom, you just get tangent A plus tangent B. For the top, it's this, then tangent A tangent B. Then you just cancel this because they are the same, right? Yeah, it's not so hard. Yeah, then you get left side. Okay, if you need, you can screenshot. But it's really simple. Let me know. Let me know when you're done. Okay, now. Yeah, let's do one more in part B. We can do it together. Ooh. How about let's do AD3 together? Sine alpha cosine. We need. So think about just the whole sine alpha and cosine alpha. Then take into tangent alpha. Right? Yeah, anyway. So if we call this is equation 1, this is equation 2. 1 plus 2. Then we have 2 sine alpha equal to A plus B. So sine alpha equal to A plus B over 2. Right? Then if it's 1 minus 2, we have 2 cosine alpha equal to A minus B. So cosine alpha equal to A minus B over 2, right? Then tangent just means sine over cosine. Then it's easy to get A plus B over A minus B, right?
Hmm.
Okay, let's go to the last section. Right triangle trigonometry. This section may be not really for those who Yeah, let's quickly go through it. This is like the definition in your right triangle. Right triangle definition. Okay, then what? UP. Yeah, here basically means either which triangle we use. If they have same shape, means they are similar. Then suppose the theta has same trigonometric ratios. Okay, still some basic thing. Yeah, here's your conclusion. For two acute angles, if they are complementary, then the sine of one equal to the cosine of the other. Yeah, it's easy to get this relation. For example, if this is alpha, then this you can call it half pi minus beta. Then it's sine minus beta equal to A over C. This is just the definition of cosine beta. So for two angles complementary, one sine is the other's cosine. Okay. Okay, now we go here. Let's quickly go through. Then it's like chapter summary and review and test. Okay, either part C, A, B, C. Let's try to find some. How about here? Use the given information to determine the value of the remaining 5 trigonometric functions to be accurate. Yeah, let me try one. How about I do this? So it's an acute angle. Even you can draw it, right? Yeah, if this is theta. How about we suppose here is 5, then here is 2, right? Then how about here? It's 5 squared, 25, minus this square is 4 times 3, so then it's 13. So take square root. So here is this, right? Then we can easily get cosine theta equal to tangent theta equal to right. Yeah, I'll not go to write the other three. Let me stop here. Now I'll give you guys chance. Ooh. Yeah, this for Ray. This for Neil. A is acute angle. Yeah, we need an exact answer. So calculator is not necessary. Yeah, just write sine and cosine. Then it's then you can stop.
Wouldn't sine be, no, wait. Then wouldn't sine A be,
Oh yeah. So this is Neil, right? Yeah, you just find sine A and sine B.
wouldn't it be kind of like this, or is there something else?
Yeah, it's kind of this, but I suppose not this. Let me see. Yeah, it's related to this, but not this. You need to modify. Then let me check what read. Yeah, I suppose this is correct. Cosine. Yeah, this is correct. Now let's talk about the 33. Yeah, you can build a right triangle. Suppose if here is angle A, then here is 2 radical minus 1. Here is 2 radical plus 1, right? Then let's think about the hypotenuse. It's square root of minus 1 square plus 1 square. Yeah, fortunately, this just equal to 2 square root take square, just 2. 2 plus 1 is 3. Double 3, you get 6. Yeah, anyway, it's 6. Then suppose your answer is this, but over 6 radical. This over 6 radical. Then it's correct. Right?
Mhm.
Okay. Yeah, if you need, please screenshot. Part B. We don't want some problem very big. Yeah, how about let's try this. 47. Right triangle definition of sine to exponent. You just suppose. Let me see. Yeah, I suppose you can explain it this way. For example, this is what I think. This is for 20 degree. This is, let me use different color. This is for 40 degree. This is for 60 degree, right? Yeah, it's not in scale. I just show this. 60. Then suppose this is like y, or let me call it height. So each of the angle equal to h over the hypotenuse, right? Hypotenuse, let me just call it c. But here has c1, c2, C3, right? So of course we have C1 bigger than C2, bigger than C3, right? H is the same. So the larger the C, then the smaller the sign value, right? Are you guys okay with it?
Yeah.
Okay. Thanks. Okay, let's stop here. Then your homework. Let's quickly mention the homework. Chapter 7. Chapter test. Yeah. So this time I would like you show your homework. I'll let parents know. Means make sure they supervise on it. You guys submit your homework. Okay? Not just say, oh, I finished all of them. I'm fine with it. This is not enough. I would like you guys can submit your homework. Okay?
Okay.
Okay, see you guys Thursday. Thank you.
Okay.